Hi everyone and welcome to Tech Nuggets. My name is Johannes and I'm here in our FEV consulting office on a rainy day in Cologne. And today we want to discuss another interesting technology which is called e-fuels. So everybody is talking about battery electrification, hydrogen obviously is a big topic, but there's even more we can do to bring down CO2 emissions. And one part of the story certainly is e-fuels, in which we want to look a little bit deeper into today. So I'm really hoping that you like the discussion of this interesting technology. And to make sure that it's going to be interesting, I've invited another expert on that topic. Please welcome with me Benedikt Heuser. All right, here with me today, Benedikt Heuser. Welcome, Benedikt.
Welcome. Good morning.
First of all, thanks for joining. We're going to talk about e-fuels. And my first question, therefore, would be, what's your background and why am I talking to you today?
So my background is that I'm pretty much dealing for more than 10 years in my professional career with synthetic and alternative fuels. For 3 years now, I'm with FEV Europe as senior project manager. In that function, I'm leading some publicly funded large projects that are really looking very deeply into production and application of synthetic fuels. Mm-hmm. And I'm also a local chief engineer, thermodynamic fuels for FEV Europe.
All right, perfect. So it seems like I'm talking to the right guy for this topic. But
hopefully,
before we are diving deep into that topic, I want to start with three very short and simple questions that have nothing to do with the topic, just to make sure that everybody gets to know you a little bit better before we start. 3 short questions, short answers. You ready?
Yeah, sure. I'm curious about the questions.
You should be. Number 1, very simple. What was your first car?
Skoda Octavia, 1.8 liter gasoline inline 4.
There you go. And quite precise also. Did you ever give your car a name?
Cheap also, yeah.
Did you ever name your car?
No, I named my motorcycle, but that's quite private.
Oh, okay, so I'm not asking all that. Then the next question would be, for you, is it motorsports or is it football?
Motorsports, definitely.
Yeah, that is obviously the right answer. And then my last question to that would be Ayrton Senna or Alain Prost?
Far before my time, I would say both, obviously.
Both. Okay, that's good enough. All right. Then thanks for that quick introduction. And we are going to start right away. Discussing e-fuels. Okay, so let's get started with clarifying some terms. First of all, synthetic fuel, that is certainly nothing new. That term is around for quite a while now. Then there is that term called biofuel, and we also have, rather newly, e-fuels. First question to you would be, can you bring that in order a little bit and explain what is behind that?
Yeah, sure. And first of all, the list you just named is really not exclusive here, so there are quite many other terms also used for the same stuff, actually. Overall, we claim a synthetic fuel, pretty much everything what is not from fossil resources. Mm-hmm. Yeah, so there might be biofuels and e-fuels or refuels, however you want to call it. I think biofuels is quite self-explaining. Here you have a biomass source, and then you take that to make your fuel. E-fuel is pretty much also called electrofuel. So there you take carbon dioxide from whatever source, mm-hmm. and renewable hydrogen, what is made by electrolysis with renewable electricity, obviously. And synthetic fuel is pretty much the overarching term you use for all that type of fuels.
Okay. And then there are quite a few more terms. For example, you could differentiate between blends and drop-in fuel. What's behind that?
So a blend, first of all, is actually a mixture of different type of fuels, different liquids. When we're referring to drop-in, that pretty much also states about the characteristics of the fuel, because a drop-in fuel can be blended at any amount or any quantity to the existing infrastructure. So the fuel as such has to fulfill the current fuel norms we are currently dealing with. So that then a drop in fuel, what you can blend up to 100% into the existing infrastructure, into the existing vehicle fleet.
Okay, so that whole topic there's quite a big fuss about that right now. And that is obviously because, as you mentioned, for example, with e-fuels, you're taking CO2 out of the air to produce fuel with it. So the idea really is to make it CO2 neutral overall?
Yeah, sure. Yeah, so the overall goal is that the car that later on uses the e-fuel just produces as much CO2 as you take from the atmosphere or from wherever to actually produce the fuel. And it's like with a tree. If you burn wood, it also releases only that many CO2 emissions that have previously taken from the atmosphere. Where you actually would take the CO2 from, they're debating if you would go for direct air capture or if you would go to point sources. In the end, it doesn't make any difference because the left pocket, right pocket. The question is what would be more efficient, at least in the short term, when actually ramping up that technology.
Right. Before we are diving a little bit into that production chain, the major criticism about all of that, I guess it's well known to you. There's a big movement towards battery electric or the overall story about hydrogen and fuel cells and all that. So you could argue e-fuels, for example, is that just the last straw to keep the combustion engine alive for you?
Yeah, that's the headline you read quite often in the newspapers from quite different magazines or authors and whatever. Definitely, we're not doing this in order to save the diesel engine or whatsoever. That is definitely not the case. In our view, it's just about that we have three different pillars for future neutral mobility. Relying only on battery electric vehicles for sure isn't enough. The same is true for fuel cells, and also the same is true for e-fuels. So none of these technologies alone is able to really have that impact what is needed to bring down the CO2 emissions in transport. So in our view, we need everything in parallel. It's not either or. It is just really put all efforts on all three technologies in order to meet the Paris climate goals. That is what it is behind. Battery electric vehicles for sure are needed. They will ramp up significantly, but simultaneously, just in Europe, we're having more than 300 million vehicles. The fleet renewable time is quite long, so just waiting for battery electric powertrains are replacing the current ones just isn't enough. So we have also to find technologies to set the current fleet CO2 neutral or at least reduce the CO2 emissions.
Well, I think you're bringing up a very interesting point because, first of all, you're saying we need to do everything, not only just one topic to achieve the targets or one technology. But secondly, you're addressing the fleet. And it's quite obvious that the fleet takes a while, all the vehicles on our streets, to be replaced. So you're saying with those CO2 neutral fuels, you can address that issue of making all those vehicles that are already out there CO2 neutral. Is that what you're saying?
That is what I'm saying. So it is really addressing the current fleet, but it might also be in addition to battery electric vehicles in the future. Also, when we're talking about climate change, we're often looking from many German national or maybe also European perspective. There are quite many other countries in the world as well. So climate change for sure is not a European or national German problem. So we also have to develop technologies for the countries that might not be that fast and really going for purely electric powertrains. So also for that countries, we have to have a solution to help them also bring down CO2 emissions of their transport sectors as well.
Well, and then obviously there are not only cars out there, right? There are other forms of transportation too, where it might not be just as easy to put a battery in. Airplanes, for example, right?
Yeah, for instance, so airplanes, ships, that for sure is not going to be electrified in near future. But there are the applications that will rely for quite a while on high energy dense fuels. For airplanes, we already discussing a quota of e-fuels already. So we're talking about in Germany 2% by 2030. That is a first step, for sure, not enough and not sufficient. But also the other type of public transport, individual transport, have to be addressed by such quotas in my point of view.
Right. So that all, to be honest, that all sounds a little bit too good, to be true. So let's talk a little bit about the challenges right now, and let's probably for that reason go into the production process and where it stands right now. Could you explain in a simple form how these kind of fuels are being produced today?
So as you said, these type of fuels, so there's not the e-fuel, so there's actually quite a bunch of different types of fuels you can think about. First of all, if you talk about e-fuels, it starts with CO2 capture and hydrogen production via electrolysis. As already mentioned before, CO2 can be taken either directly from the atmosphere, so there's a drawback, of course, is the quite low concentration to filter CO2 out of the air, but you can also go to point sources. If you have biogas plants, for instance, they have very high quality, high density CO2 concentration in the gas, roughly 30%. So that is way easier to really capture the CO2 out. So in short term, for sure, we will go to point sources, but in the long term, we will definitely also have significant amount of CO2 direct air capture. If you then have hydrogen and CO2 at hand, you can go, for instance, to Fischer-Tropsch synthesis. It's quite known technology for almost a century. With that type of technology, you can make, for instance, kerosene for airplanes. You can make diesel type fuels. You can make waxes, but you can also have a fraction of gasoline type fuels. Another pathway could be that you start off with methanol synthesis. Methanol, of course, can also be directly used as fuel. And in China, we see this, that they are running their taxi fleets with neat methanol already. They do have heavy-duty powertrains running with methanol. We think that is also a very interesting fuel for marine applications. But for a passenger car, talking again about drop-in backwards compatibility, methanol would be the starting material for the MTG process, what is methanol to gasoline. And by that process, you can really make a compatible fuel that is feasible for all gasoline-type cars out there on the streets already.
Okay. So when you read the news, you see, for example, that Porsche is doing that together with Siemens, I believe in Chile.
Yeah.
So what's stopping us? What is in that production process the big hurdle right now that's keeping us from, pouring it into any vehicle tomorrow?
It's not actually the production process what is stopping us, it's legislation. Because currently, if you look at the whole value chain, you mentioned Siemens already and Porsche. At this point in time, there's actually no one of the stakeholders who has a significant benefit of investing into that technology. I think it's not a secret that technology for sure is quite costly. If you would ramp up that type of facilities in really large amounts, it's easily in the €1 billion investment. And if you do not have really benefit of that, either monetary or ecologically, you won't do this. And that is why we are also trying to convince politics about the benefits, why we do need that type of fuels, so that there will be legislation, that there will be incentives for stakeholders to really invest into that technology. And I think what Siemens and Porsche are doing in Chile is awesome. So that is the step we need. That is really industrial stakeholders proving politics and public that technology might work and that there is a significant interest to really go that way.
Right. So you already mentioned it is quite costly. Big question then for me is, once we are there, will I be able to afford that fuel?
Keep fingers crossed. Yeah, no. It will be for sure more costly than fossil fuels today. Because honestly, what can be cheaper? So some easy words. What can be cheaper than drilling a hole into the earth and you have the fuel almost at hand? And it can't get any easier than that. If you want to go to CO2 neutral mobility, it is going to be more costly than what we have today with fossil fuels for sure. And there it doesn't matter if you go to fuel cell, battery, or e-fuels. It's almost more expensive than fossil fuels. We definitely need incentives for synthetic fuels, as we do for battery electric vehicles as well. In the long run, so after 2030, we think that synthetic fuels can be produced at roughly €1, €1.50 per liter e-fuel. That is about 2, maximum 3 times more expensive than producing fossil fuels. So we have politics to make incentives to really produce that fuels and also for the customers to buy it. That might be by adapting the energy tax we currently have, so moving away from energy tax to fossil carbon tax on the fuels, and then we would quite easily have a leverage price between the different types of alternatives. And then the customer for sure will buy these type of fuels.
That makes sense. So in the end, again, it's a political question where to put the incentives on. Is it on the fossil fuel and on which one? Or is it on the e-fuels to make it attractive for the end client? But the end client ultimately wouldn't feel a difference?
It wouldn't feel a difference in hardware whatsoever. Just a difference that you're going green. And I think that
which is a good feeling, I guess.
That definitely is a good feeling, I can tell. So in our project, we have the first cars running with our synthetic fuel we produced, for instance, in C3 Mobility, jointly with the partner. And I have to tell that it's awesome. You're currently running the car or the motorcycle or the truck whatsoever with the green fuel. And that is a really good feeling. And I hope that everybody will enjoy this type of feeling in the future as well.
So you have some of the e-fuel available right now?
We do, yeah. So Chile and Porsche, they are just starting their industrial production facility. In C3 Mobility, we produce jointly with the partners at the university in Freiberg roughly 45 cubic meters of synthetic gasoline. And this we have tested in the engines and cars of our partners. Very, very good outcome. So the fuel not only fits the current legislation, we also see that pollutant emissions slightly drop without any change in engine vibration or hardware. So you have your levers, you have to also tune the fuel characteristics. And the benefit is that we're not only going CO2 neutral, what is already a really quantum leap, I would say, but you can also further reduce pollutant emissions. And the combination of both, I think, is really very, very interesting.
All right. Well, as a last question, let me get back to the point that you made before about biofuels coming from biomass. Now, there's a whole range of different biomass that you could use for that. And there was also some criticism about that in the past. What would you think, looking into the future, where this biomass is coming from?
So for sure, it is not first generation anymore. So we're not really growing plants that you could also eat or drink whatsoever. Biofuels of the future will be either second generation or even third generation. That means you're using residues. So that might be lignocellulosic material, also for ethanol production. The amount for sure is limited because also there's more than one stakeholder who would be interested in the raw material biomass. So you can use it for your pellet, for heating purpose. You can make biogas, you can make biofuels. And that is also why we think that we cannot only focus on either biofuels or e-fuels. So same for battery and fuel cell and
fuel. You need everything.
And need all the sources we have, all the raw materials we can gain to make it also very cost efficient.
All right. Okay, Benedikt, thank you very much for that great overview. I think we all understood it a little bit better now, hopefully. At least I do. So thanks for joining today. I hope you enjoyed it a little bit too.
I did, definitely.
Perfect. Well, and then to everybody watching or listening in, I hope you liked it too. If you did, please let us know. If you have some ideas on technology that you want us to discuss in one of the next episodes, please also let us know. Until then, I say thank you very much for tuning in. Cheers. Bye-bye.
Bye.